Welcome to IMI Cornelius, the leader in dispensed beverage solutions. This instructional video will assist installers on the setup and operation of the Quest dispenser. Assembled in Glendale Heights, Illinois at IMI Cornelius's U.S. headquarters, the Quest dispenser provides operators with an efficient and effective dispense platform for juices, teas, cold coffees, and other beverages. The Quest dispenser uses an ice bank water bath system to cool both the potable water supply and the concentrate cabinet. Accessories and options for the Quest dispenser include a choice between push button, press and hold, or 4-size programmable portion control, a tall cup kit that increases the cup height capability of the dispenser when using pitchers or carafes, an installation kit for ambient concentrates in the larger bid packages, 3 of 5 gallon, that do not fit into the dispenser, and an optional cup locator for counters that may be too low, making the dispense nozzles not easily visible from the front of the unit. Every dispenser comes with the following: an installation guide that provides more detail for the information we are covering in this video, an owner's manual, a list of spare parts, 2 sets of magnetic flavor strips, a laminated cleaning and maintenance card which you, the installer, will need to review with the dispense operator, 4 4-inch legs, water supply line, and a drip tray and grill. The merchandiser door front is packed separately from the dispenser in this carton. Set this aside, it will be mounted on the machine later. Before setting up the Quest juice dispenser, make sure you have the necessary tools and a proper designated location. The following tools are needed: a 9/16 open-end or adjustable wrench, a Phillips head, and both small and large-bladed screwdrivers. The space required for proper installation should allow for a minimum of 12 inches, 30.48 centimeters, off the top, and at least 4 inches, 10.16 centimeters, off the back. This is to ensure proper airflow for the refrigeration system. The operating weights of the Quest units are significant. Be sure that the counter you are using is level and strong enough. All Quest dispensers arrive mounted to a wooden pallet. Remove the dispenser carton box by cutting and removing the straps. Carefully remove the staples, located on all 4 corners, by prying them out with the large-bladed screwdriver. A pair of pliers may also help with the process. Now, slide the carton up and off. 4 9/16 bolts fasten the dispenser to the pallet. There is 1 in each of the corners. The best way to remove them is to tip up the dispenser until you can get a wrench on the bolts themselves. Loosen each bolt until they can be removed by hand. 1 by 1, remove each side. Be careful removing the last one, as the unit may slip off the pallet. Now the pallet can be removed. Once you have removed the dispenser completely, the empty box and pallet can be discarded. Be aware that help may be needed to lift the dispenser onto the counter since it weighs 120 pounds. Locate the dispenser legs packed inside the refrigeration cabinet. The legs screw into the same holes as the bolts that held it to the pallet. The Quest dispenser can be operated with or without legs. We advise you to check with your local area health inspection guidelines. Most installations will require 4 4-inch legs so that the machine can be cleaned underneath. Some customers choose to operate the unit without the legs to accommodate a height restriction, and this can cause a restriction of proper airflow, which in turn can cause the refrigeration system to work harder. Once the dispenser is situated properly on the counter, the next step is to fill the water bath.
Hi, I'm Doug, and I'm going to walk you through the technical aspects of the Cornelius Quest juice dispenser. Let's start by filling the water bath. To fill the water bath, it's very important that we keep the machine unplugged. This will assure that we keep the proper level.
To access the water bath fill tube, remove the front splash panel by removing these 2 screws. Be sure to put the screws into place for safekeeping. You'll need them when it comes time to replace it. The splash panel comes with a peel-off vinyl cover to protect from scratches during shipping. Pull this protective wrap off and discard the vinyl. The dispenser comes with a 3/8 flare fitting connection on the water bath fill line. It's hidden here behind the retaining cover. This is our overflow. This is our drain for the cabinet condensation, which we'll talk about later. Now, take the fill tube, cut the wires, and stretch it out. Next, remove the fill tube retaining cover. You only need to loosen the screws and then slide the cover up and off. Then, remove the drain cap and attach the fill tube using the elbow end. Use only your hands to tighten. Using the elbow end keeps the shutoff close to the dispenser. The water supply should be consistent with proper water standards and should not be connected to a water softener. There are 2 washers in the dispenser's information packet that will be used to hook up the water line to the water source. They will go on both ends of the fill line at the source and at the dispenser itself when we finally hook the water line. Now, attach the fill tube to the water supply outlet. Be sure the shutoff valve is in the off position before turning the water on at the source. It is advisable to mount the drip tray to catch the overflow when the water bath is full. Now we are ready to fill the water bath.
Begin by slowly opening the shutoff valve.
And continue until it is opened all the way. Fill the water bath until you see water begin to run out the overflow. The water bath holds approximately 3 gallons on the Quest 4 flavor and 1.5 gallons on the smaller 2 flavor. It is very compact, and the water enters in directly at the center bottom of the tank. Filling it too quickly in the beginning can cause the water to overflow out of the top of the ice bank cover, thus getting water on the counter as well as possibly wetting major electrical components mounted to the cover itself. Now, turn the valve to the off position and disconnect the supply line from the fill tube. Verify the level by holding the fill tube straight up and checking to see if the water line comes right below this inlet fitting. If it does, then the water bath is properly filled. Next, replace the fill tube cap. Do not over-tighten, as it could damage the inlet fitting. However, be sure it is tight enough so that there are no leaks. Tuck it back in the channel and replace the retaining cover. Now we are ready to plug in the dispenser.
Quest dispenser requires a dedicated 15-amp circuit, 115 volts, 60 hertz. When you first plug in the dispenser, you will hear the agitator motor and the cabinet fan running. You will notice the refrigeration system does not immediately activate when the unit is first plugged in. That is because there is a 3-minute start delay built into the system. This is done to allow the refrigeration system time to equalize in the event of a power loss. After the compressor and condenser fans start operating, the ice bank begins to build and cooling begins. It's always a good idea to get the ice bank filled as early as possible. This will allow enough time to give the dispenser a sufficient amount of cold water that will be required for proper calibration of the finished drink.
Now let's connect the water line. Remove the dust cap and discard it. Locate the water connection on the back of the dispenser. Be sure to use the fisheye washer provided in the installation kit. Insert the washer inside the elbow fitting, push it in hard, and carefully attach the water line to the back of the unit. Hand tighten to be sure you are not cross-threading it on the fitting. Then snug it down with the wrench, but be careful not to over-tighten, which could crush the gasket and cause a leak. Now, open the shutoff valve and water will flow to the dispenser. Check for leaks at the water connection. Go to the front of the unit and press the dispense button. Hold it until the water flows and all air is purged. This may take a couple of seconds. Repeat this on all the valves. Correct and consistent water pressure is very important to the successful operation of this dispenser. The Quest dispenser has an operating range of 30 psi to 80 psi with an optimum pressure of 50 psi flowing at a volume of 3 ounces a second. If you have water pressure issues, especially where you think that the pressure is too high, a SureFlow flow control set at 50 psi is available that can be spliced into this line to allow for good and consistent water flow to the dispenser. Locate the merchandiser that came in the separate box and peel off the protective paper. The merchandiser comes with a handle and door lock already installed. Mounting hardware, lock and key, and instructions are included. Notice the 6 mounting points as shown. 2 screws at the top, 2 screws on the sides, and 2 screws at the front of the merchandiser. We've loosened the screws in the front switch panel using a Phillips head screwdriver. Now slide the merchandiser in place and mount. There are two types of products that work in the Quest dispenser. The most important point to remember with a frozen concentrate is to make sure that the product is thawed before loading it into the dispenser. The product must be in a liquid state at about 35 to 40 degrees Fahrenheit. Be sure it flows properly through the pumps and mixes properly when dispensed. Frozen concentrates have a little tab on the side of them called the vent tab. It is extremely important that the vent tab is pulled and the bottle is vented, allowing the concentrate to flow properly. If not properly vented, no air will get into the bottle and it will eventually collapse. If this occurs, you will get a sold out signal even though the bottle is still 3/4 of the way full. The second type of product is a shelf-stable product known as bag-in-box. This product does not need to be refrigerated and therefore does not need to be prepared in any special way. Bag-in-box products do not have a vent tab, hence they automatically self-drain. Pull the dust cap off the nozzle and place the concentrate on the dispensing platform shelf inside the cooling cabinet. Load concentrate containers by sliding them into the dispenser cabinet and pressing down until the nozzle is fully inserted in the receptacle, also called a bottle adapter. Once it engages, the concentrate will start to flow into the pump system. Prime each pump by pushing each individual dispense button until you start to see water and concentrate flow through each nozzle. You've purged the line and the concentrate is loaded. Now you're finally ready to do the calibration.
Each concentrate has what is called a Brix setting. Brix is a percentage scale of the amount of sugar solids in a drink or juice concentrate. For example, 1 degree of Brix equals 1% sugar. Orange juice, for example, is an 11.8 to 12% Brix, meaning that's 12% sugar in the finished drink. Now, most of the time, Brix is set by taste, but we don't recommend that. To get the most consistent drink and the best tasting drink, the use of a refractometer is required.
A refractometer measures the amount of sugar in the concentrate. They work using the principle of light refraction through liquids. When passing light through a liquid, the refracted angle will be shown on a scale determining the amount of dissolved sugars in the drink. Most of the time, when measuring concentrate, the scale will read between 11.8 and 12. As stated before, orange juice is always 11.8 to 12 as a finished drink, with some apple and cranberry setting as high as 14. The first step in setting a Brix is to take a flat blade screwdriver and turn the flow control counterclockwise until it stops. This shuts off the water flow to the controls. Now, turn the flow control 2 turns clockwise. You should be fairly close to the 11.8 Brix setting. Next, draw a drink sample from the nozzle. We recommend dispensing about 8 ounces of juice into a glass or cup. Make sure you stir it once or twice, then place a clean straw in the middle of the sample and with your middle finger over the top of it, draw a sample from the cup. Take that sample and put it on the glass or prism of the refractometer. Close the lid and look at the Brix reading inside. If, for example, the Brix reading is high at 14, there is too much concentrate and more water is needed. To make that adjustment, take the flat blade screwdriver and imagine that the flow control is the face of a clock. If you are at 14, turn the dial precisely 3 minutes clockwise. If, for example, the Brix reading is too low and somewhere down at 10, the water needs to be decreased. To decrease the water, turn the control flow dial counterclockwise precisely 2 minutes. Close the door and draw another 8-ounce sample. Stir it and repeat the process. Continue to repeat this procedure until you get a Brix of between 11.8 and 12, depending on the type of PF concentrate used, apple, orange, or cranberry juice. Be sure to wipe it clean before putting another sample on the prism and taking the second reading.
The key to achieving an accurate Brix reading is temperature. This is why getting the water bath filled early during installation is very important. It ensures that there will be plenty of cold water and the water is at the proper temperature when adjusting the Brix. One way to validate the temperature is to put your hand under the dispenser and check it. Yet, a more accurate reading is to take a dial thermometer and place it in a cup of water before beginning the Brix procedure. If the water reads between 40 and 45 degrees Fahrenheit, you will get an accurate Brix reading with the refractometer. When using an ambient or bag-in-box concentrate like apple juice that has been sitting on a shelf and not pre-chilled, it's extremely important to set the Brix on the machine at a slightly higher rate. so set the bricks to a reading of about 12.3 to 12.4. Optimum water flow to the dispenser is 50 psi. The minimum that the unit needs to run is 30 psi. If you choose to run at 30 psi, be aware that there are concentrates such as apple, cranberry, some blends, some teas, that where 30 psi may not be giving sufficient water to set the proper bricks. There is a speed switch mounted for each individual pump. There is a high and low setting for each dispense head on the dispenser. By default, the dispenser is set at the high setting. For almost all concentrates and most applications, you will run in the high setting. Orange juice and your citrus-based juices will always run at high speed. Once you finish calibrating the machine, replace the front splash panel and put the magnetized flavor strips on the unit. Another way to calibrate finished drink is by using this separator and ratio cup. It separates out the water and concentrate to a measured ratio. 4:1 or 5:1 is typical for juice. This separator assembly and cup is available from IMI Bevcor. Be sure to use the cup that is calibrated for the specific ratio of concentrate being used. With the nozzle removed, we insert the separator into the dispenser and rotate. The large tube will be the water. The smaller tube will be the concentrate. We then set the bricks cup underneath at the corresponding sides. We press and hold the button until we measure an amount. On a flat surface where the line crosses the two line up is a proper ratio. As an installer, the operator may look to you for training on how to operate the dispenser and the best practices for basic cleaning and maintenance. Take this as an opportunity to properly educate the end user and turn it into a win-win for both of you. Proper training at this early stage reduces the number of service calls and, more importantly, gives the operator and customer a good quality finished drink. It's important to review the cleaning and maintenance procedure with the operator. Along with the instructions on how to install the machine, there's also this laminated care and cleaning card that comes in both English and Spanish. Additionally, a full-color door label that covers the same procedures is attached to the inside of every unit's cooling cabinet door. When training the dispenser operator, make sure he or she fully understands the importance of keeping the machine clean and how to maintain it properly, because it reduces the number of service calls and dispenser downtime.
Each flavor has a dispense flush mechanism. With the door open, select the flavor that you want to flush and locate the dispense flush lever, which is under the front flap on the platform assembly. Slide the lever handle to the right into the flush position. Put an empty cup or glass on the drip tray underneath each dispense nozzle. Close the cooling cabinet door and press the dispense button until clear water flows from the dispense nozzle. This flushes the entire pump from the nozzle into the mixing chamber and the pump itself. Open the door, lift the flap, and move the lever back into dispense. Close the door and press and hold the dispense button until you start to see a colored liquid from the nozzle. Repeat this procedure for every flavor. We strongly recommend daily cleaning of the following parts using a mild dish detergent: cup rest, drip tray, dispense nozzles, and mixers. The dispense nozzles are held by protruding little wings on opposite sides of the nozzle opening. We reference these wings when we're installing and deinstalling the nozzles. The static mixers are inserted to the top of the dispense nozzles and look very much like a giant screw. To remove the dispense nozzles and static mixers, rotate each 90 degrees and pull it down from the dispense compartment. Imagine the numbers on a clock. Put the nozzle wings in the 6 and 12 position, or north and south, and pull straight down to release. When cleaning is done, it is extremely important to make sure each nozzle is locked into position. If the operator sticks it back and doesn't rotate it, there's a chance that the nozzle and its attached static mixer will end up in a glass when the first cup is dispensed. To lock the nozzle in place, reinsert and rotate it 1/4 of a turn to a 3 and 9 or east and west position. Do not put these parts in a dishwasher or soak them in any kind of chemical cleaner. Only mild soap and water should be used for the daily flushing or for the daily cleaning. It's also a good idea to use a clean damp cloth to wipe down the external cabinet and the splash areas periodically.
Operators will sometimes use the flush mode as a security measure for securing the dispenser. For example, in an environment where the machine is not secured, operators will put it into the flush mode so that only water is dispensed. If you use the flush mode to dispense water, there's a good chance that the pump tubing will split over time. This will be discussed in more detail in the pump platform assembly part of this training.
Here's a better way to secure the dispenser from having concentrate dispensed. Open the cooling cabinet door and locate the on-off switch on the inside. You will notice that there are two switches inside the door. The one on the right manages the pump platform and its operation. Pushing this right switch to the off position disables the dispenser's pumping feature. However, the refrigeration always remains in operation while the unit is plugged in. The second one is for lighting up the merchandiser. Switching this one to the off position turns off the merchandiser light so that when the machine is shut down overnight, people will know that the dispenser is not active. Once both switches are in the off position, close the cooling cabinet door and lock the door with the key.
There are times when the dispense platforms must be removed from the dispenser for cleaning. Keep in mind that this is a 4-flavor machine and there are 2 individual platforms. Shutting off the water is not necessary in order to clean this dispenser. The platforms can be removed with the water connected and the units plugged in.
The first step in cleaning the dispenser platform is to remove the dispense nozzles. Again, turn the nozzle 1/4 turn so the wings are forward to disengage the nozzle from the dispenser. Then, pull the nozzle straight down to remove it and the static mixer. Step 2. Remove the concentrate shelf. Lift it up to pull the rubber grommets up and off the bottle adapters. Step 3. Pull and lift the front flap door out. Step 4. Unlock the platform clips. Pull on the catch and slide it back to unlock the platform clips from the dispenser. Step 5. Gently lift the platform straight up and begin to pull it forward. Step 6. Release the water connector. The water connector is released by pressing the gray button on the water coupler. After releasing the water connector, pull the tray up and finish pulling it forward until the platform connection is separated from the dispenser. Step 7. Disconnect the electrical connection. With the platform pulled halfway out, disconnect the electrical connection inside the cabinet by squeezing the 2 side release wings on the plug and pulling them straight back. This enables you to lift the platform completely out. Removing this cable plug can be a little difficult since it plugs in very tightly to keep moisture out. Once the platform is taken out of the dispenser, it can be cleaned with mild detergent. Never submerge it in a sink, place in a dishwasher, or allow excessive moisture into this area. Step 8. Remove the mixing chamber. During the sanitizing procedure, the mixing chamber will be sanitized. However, it should be cleaned every time the platform is removed. Take the mixing chamber out and rinse it with warm soapy water. Don't forget the syrup and water ports. Once you've cleaned both dispenser platforms, reverse the steps just reviewed to reassemble the machine.
Now it's time to increase our knowledge of the internal workings of the Quest Juice dispenser. In this section, we are going to cover the theory of operation of all the major systems. This will include a major component review and some simple troubleshooting tips to validate that the system is working as designed. Now let's begin.
Okay, let's dive right into the technical aspects of the Quest. To do that, we have to first remove the cabinetry. Remove the front splash panel's 2 screws and pull straight down. This should be done with the drip tray removed. The cabinetry comes off in a specific sequence. The first panel we need to remove is the top cover. Loosen and remove the screws that are located here in the back corners. With the cabinet door open, lift the panel from the rear, rotating it slowly from one side to the other to release the front clips. These clips are plastic, so be careful. We don't want to break them. The next panel to be removed is the back panel. This panel can be removed with the unit plugged in and the water line attached. The back panel is held on with 4 clips. Grab the back panel from the top and gently pull up until both sides release. Now gently guide it around the water line and then the cord by pulling forward. The 2 Flavor Quest's back panel is secured with the hardware that also attaches the side panels. Now remove the left-hand panel by removing the 2 rear screws and the striker plate on the front. Pull the back of the panel away slightly from the unit and gently slide forward, releasing the front clips. Removing the right-hand panel is a little tricky because of its proximity to the cabinet door. Once you have removed the back screws, open the cabinet door so it is parallel to the unit. Pull the panel slightly forward at the back to clear the frame. Tip the panel forward from the top to about a 45-degree angle and gently push up and forward. This will release the clips. Now slide the panel down and back, releasing it from the dispenser. This is a 1/10 horsepower hermetically sealed system with a copper evaporator building a 16-pound ice tank to chill the potable water coil submerged in the water bath. The control is an electronic IBC, or ice bank control, using a 3-prong probe. The concentrate cabinet is cooled by circulating the cold water from the water bath up into the cabinet by the agitator pump motor. The water flows through a small heat exchanger located at the rear of the concentrate cabinet. The cabinet fan then circulates the air by drawing the warm air in from the top and blowing across the exchanger and out the bottom. There are no temperature controls to adjust on the Quest. The cabinet temp will run at about 40 degrees and the water will be dispensed at 40 degrees or less, depending on the incoming water temperature. The IBC, or ice bank control, is a solid-state design that, by means of a probe assembly that is strategically located in the water bath, controls the refrigeration on and off cycle time. It accomplishes this by being able to sense the resistance difference between plain water and ice. The control has a built-in 3-minute delay before calling for the compressor to activate. If there is any interruption in power to the dispenser, whether it's unplugged or if the incoming power to the building is interrupted, the system will wait the 3 minutes before activating the refrigeration system. The IBC failure mode is deactivated if there is no or not enough water in the water bath to cover the probe assembly, or if there is a break in the continuity, as in a broken wire or connector, the control will not activate. Be sure when filling the water bath that the mineral content in the water is sufficient. It is suggested that regular tap water be used. Distilled or some bottled waters have the minerals removed to the point that the controls cannot sense them and therefore will remain in the deactivated state. The IBC works off of line voltage that comes into the control here. The agitator pump motor is plugged in at this position. This is pass-through voltage only, as this motor runs any time the unit is plugged in. This is the outlet that leads to the compressor and evaporator fan, and this is the probe. All the connectors are keyed so there can be no mixing them. The ice bank control is located here. To access it, we need to remove the nozzle and the electrical box. It now can be slid to the right to release from the unit. Once released, it can be pulled straight out to gain access to the connectors for system checking and troubleshooting. The condenser and fan assembly is located here in the back of the unit. The Quest 4, as you can see, is mounted horizontally while the condenser on the Quest 2 is vertical. The condenser fan is wired in series with the compressor itself. When the IBC calls for cooling, a relay closes, sending line voltage to both this fan and the compressor. As you know, good airflow through the condenser is critical to good refrigeration performance. To clean the condenser, we first need to remove the motor fan assembly. This is done by simply removing this screw and rotating the assembly counterclockwise until the tabs clear and the motor can be lifted out. Be careful when removing the fan assembly, as the refrigeration cap line runs across the back. Snagging or nicking this can cause a major refrigeration leak. The compressor is a 1/10 horsepower capacitor start induction run motor. It has 2 sets of winding, start and run. To properly understand how it works, we need to first examine the electronic components. They are located under this cover. To remove, insert a screwdriver in the slot and gently press down while at the same time pulling the cover back. In this application, the capacitor is used for startup only. It is wired in series with start winding and, by discharging, helps to increase the compressor motor's starting torque. This is a current magnetic relay. It works much like a solenoid valve. A spring holds the relay open when the system is idle. When the control device, in this case the IBC, closes and sends line voltage into the compressor, the relay becomes magnetized and closes the contacts. This action energizes the start winding circuit and the motor inside the compressor starts. As the motor speed picks up, the amperage draw decreases, thus reducing the magnetic field in the relay coil, and the spring then opens the contacts, de-energizing the winding circuit. This is a snap-action bimetal motor overload protector. When the bimetal discs, usually steel and copper, reach a certain temperature, they snap back, opening the circuit. When cooled, they assume the closed contact position. The temperature can be caused by a high compressor shell temperature, lack of proper airflow to the unit, or a high amperage draw from the compressor motor itself. A bad start cap or locked compressor motor can cause this to happen.
Our first step in troubleshooting is to do a basic system validation. This will tell us if the IBC is calling for the refrigeration system to activate and the components, the fan, and the compressor are running when called.
First, we must remove the IBC from the unit. This is done by sliding the box to the center of the dispenser to release and gently pulling forward until it can hang off the front of the unit. This will expose all the connectors. Next, we need to remove the probe connector, which is the one on the far left side of the box and is marked with a picture diagram. These connectors are very tight. Using any kind of pliers or gripping device will crack and break the connector cover. The best method to remove this is to use either an adjustable crescent wrench or a 7/16 open-end wrench. Slide the wrench across the connector and gently rock up and down. This will loosen and raise the connector out of the IBC so it can be easily removed. Now we are ready to validate our refrigeration system. There are two ways to accomplish this. One, if we have an extra loose probe, we can plug that in the slot and place it in a glass of tap water. After the 3 minutes, the ice bank control or IBC should activate the fan and compressor. If we don't have an extra probe, we can accomplish the same result by taking a pair of pliers, gripping the middle connector or terminal, and at the same time touching the other two. We are simulating the probe being covered with water, thus closing the circuit. Again, after waiting the 3 minutes, the condenser fan and the compressor should start. The condenser fan and compressor are wired in series. If voltage is getting to 1, then unless there is a break in a wire or a problem with the electrical components of the compressor itself, the compressor should be operating. Be advised that this compressor runs very quietly. It may be necessary to place the blade of a screwdriver against the shell while placing your ear on the handle. This, plus the heat on the discharge line and shell, will tell you the compressor is running. After we have run the system for about a minute, let go of the pliers and you will get a 45 to 60 second delay and the compressor and condenser fan will shut off. What we have done with this test is validate that indeed the IBC operating circuit is sending the signal to the compressor and that the relay has engaged to send voltage to the condenser fan and compressor to activate the refrigeration system. At the same time, we have also checked that the relay is disconnecting properly. If during our system validation test the condenser fan runs but the compressor does not, we will have to use our voltmeter to run some checks on the compressor and its key components. Start with the start capacitor. If the compressor attempts to start but is unable to because of a bad start capacitor, you will hear it tripping out on the overload under this cover. It will be a metallic sound about every 4 to 5 seconds. Caution! You need to be sure the capacitor is fully discharged before making any attempt to remove the wires. It is best to use a screwdriver with an insulated handle placed across the posts. If the capacitor is good, a small spark will occur. If the compressor is silent, check to see the line voltage is indeed reaching the compressor. You do this by placing your volt-ohm meter probe on the overload lead and the neutral lead on the relay itself. If no voltage is present, check for loose or damaged wire connectors. The next tests require that the dispenser be unplugged. After you have discharged the capacitor as we stated above, remove the overload and relay from the compressor. The relay is removed by pulling straight back. You now see these 3 pins. The top pin will be referred to as the common pin. The left side is start and the right side is run. Now we will measure the resistance across these pins. Common to start should be about 3 ohms, common to run should be about 10 ohms, and run to start should be about 12 ohms. If any of these read 0 ohms or infinity, then the compressor will need to be replaced. Now we need to check each post to the compressor shell to be sure there is grounding to the compressor shell itself. Scratch the paint off the compressor to be sure of a good contact and measure each post. They all should read infinity. If resistance reads 0, then there's a direct short and the compressor will need to be replaced. Check the overload for signs of overheating. A dirty condenser or restricted airflow to unit will cause the system to trip out on the overload. Also, if the start capacitor is bad and not discharging, this could be another cause for the overload to trip the system as stated above. Check the relay for any signs of overheating. You can check the continuity of the relay by placing the volt-ohm meter in the continuity setting, placing one probe in the start terminal, and, where the power wire attaches, turn the relay upside down. If the contacts are good, the meter should beep.
It's always good practice that when in the field, you should replace all the compressor components at the same time. Be sure to use the correct parts when replacing.
Now we plug the probe back into the IBC and, with the unit plugged and a full water bath, wait the 3 minutes. The refrigeration system should turn on. The fail-safe mode on the IBC is activated when there is no water in the water bath tank or there is a break in the continuity between the end of the probe and the connector, as in a broken wire, on any one of the legs. If this is the case, the IBC will not activate and the compressor and condenser fan will not come on. Inspect the wire connectors for any loose or bare wire. A slight tug test on each connector could expose this issue. Be sure, however, when replacing the connector, you get the wires in the proper order.
The other critical piece of the cooling system in the Quest dispenser is the cabinet cooling system. We take the 32 to 33 degree water out of the water bath tank and we circulate it up through these lines by means of the pump agitator motor. It goes then into a heat exchanger which is located in the back of the cabinet. In front of that heat exchanger is a fan. This fan then circulates the cold air through the cabinet, keeping it at 40 degrees.
This motor performs 3 very important functions. It circulates the ice bath water to cool the cabinet. It ensures that the ice bank itself is uniform and not growing into the water coils, thus preventing freeze-up and water stoppage. It also is very important to the cooling system operation. The agitating of the water is directly responsible for the heat exchange of the incoming potable water that is in the water coil itself. Note: there is absolutely no temperature adjustment on either the cabinet or the finished drink.
If you experience a warm cabinet and the water from the valve is at least 40 degrees or below, then the agitator motor is at fault.
First, you check to see if the red wheel mounted to the motor is spinning slowly or not at all. If it's spinning slowly, you are not sending the cold water into the heat exchanger, therefore no cooling is taking place. This and the cabinet fan both run when the unit is plugged in. There is no on-off on this system. Refer to the training manual for removal and replacement of this motor.
This next section covers the dispensing electronics. These are the circuits and components that are used to operate the pumps and water solenoids. Again, we're going to follow the same protocol as we did on the refrigeration section. System overview, major component review, and troubleshooting.
The transformer has a primary and secondary output. The primary comes through the blue wires and operates the pump circuitry. This output voltage is 26 volts AC. The second output comes off of the red wires and it is 24 volts AC. This is used to power the ballast board on the lighted door merchandiser. This transformer is equipped with overload protection. Should it become overloaded and a build of heat occurs, the transformer will kick out on the overload. When cool, the overload resets. It does not have manual reset capability. The function of this switch is to reset the refill system when the dispenser has run out of concentrate. We'll go into more detail on the out-of-concentrate system, or OCS, later. This switch can be found in 2 different locations based on the version of the dispenser you are working on. The current location is in the upper left side of the inner door. The second location is found in the door latch itself, located on the right side of the dispenser. When the door is open, the switch disengages the 26 volts AC from the transformer and thus disables the pump platforms. Located inside the door are 2 switches. One is to shut off the merchandiser. The other is a pump platform disabling switch. This is wired in series with a door reset switch and shuts off the 26 volts AC from the transformer to electrical box, thus shutting off the pump platforms themselves. The electrical box is located in the lower right corner of the unit, mounted to the water bath tank cover, held in place with 1 screw. It's what we like to call plug and play. It contains the voltage regulator boards, VRB, for each pump head, a fuse, and speed switches for slowing down the pump motors themselves. The box plugs into 2 cable connectors. The white is the input side and the red is the output side. Now let's take a closer look at each component in the electrical box and its function. Located in the fuse holder, this is in series with the switches on the one side of the transformer power leg. When this fuse is blown, the 26 volts AC is shut off to the VRB boards themselves and no dispensing will take place until it is replaced. This is the key component in activating the dispensing system. It incorporates the relay that, when the dispense button is pressed, closes, activating the electronics to open the water and platform solenoids and at the same time energizes the concentrate pump for that one valve only. To do this, it converts the input voltage from 26 volts AC to 28 volts DC output. The capacitors located on the board are used to boost the output voltage momentarily to 32 volts DC. This is to open the solenoids and to give the pump motor extra torque for starting. This is the long row of connectors mounted at the bottom of the VRB board. Each connector position is labeled. Starting from the left, there is a 2-pin connector marked Power. This is the 26 volts AC coming in from the transformer. Next is a 2-pin marked Sold Out. This is the connection for the sold out system input from the corresponding bottle adapter on the dispense platform. We will review this operation later. Last is a 4-pin connector marked Door. This is the connector that runs to the dispense activation switches on the door and also powers the concentrate refill light located on the dispense switch pad. This is the 4-pin connector located close to the mounting bracket. It is the 28 volts DC when the dispense button is pushed. Again, the connectors are marked. Solenoid. This refers to the water inlet solenoid that is mounted on the rear inlet fitting. Pump is the water solenoid and pump motor of the dispense platform. During dispensing, the process of converting the step-down line alternating current voltage to direct current voltage causes heat to build at this drive transistor. Since each VRB has a built-in thermal cutoff that shuts down the direct current voltage output if too much heat is generated, we must draw this heat away by means of a heat sink device. Since the mounting bracket is metal and diffuses heat, we attach the drive transistor to the bracket to be sure it maintains the proper operating temperature during dispensing. However, there is another, more important reason for this hardware. Because voltage is present in the drive transistor when it's active, we must ensure that we are not grounding it through the chassis, as this will cause a short circuit and damage the VRB. We do this by means of this insulating pad and shoulder washer and screw. These parts must be present and in the correct order. The shoulder of the washer up inside the hole in the drive transistor and the pad in place between the bracket and the chip itself. This will ensure no contact with the bracket or the screw, but still be able to draw the heat. Every VRB replacement board comes with this hardware. The VRB board comes with the ability to do a lower speed. This is accomplished by placing in series with primary and mounted drive transistor a second transistor. When the speed switch, mounted to the front of the electrical box, is placed in the low position, it engages the second transistor into the circuit. After initially starting as 32 volts DC, in a millisecond, the second drive transistor removes approximately 10 volts DC from the circuit, thus producing an output of approximately 18 volts DC. Since all the heat is in the primary, we do not need to draw heat from the secondary transistor. Low speed is used only for the rare times when the water pressure to the dispenser is low enough that some concentrates, usually clear-based ones such as cranberry or apple, cannot achieve a proper Brix because the concentrate pump at high speed is dispensing too much volume. Slowing the pump speed lowers the pump's output. All Brix calibration should be done with the speed switch in the high position, as it optimizes the flow from the nozzle. Located below the 2-pin connector, that is for the speed switch interface marked speed, is a 3-pin jumper marked LKJ5. This is used in conjunction with sold-out refill circuitry. When placed in the LK position, covering the LK pin and the middle pin, and the concentrate runs out of package and the sensing pins are exposed in the bottle adapter mounted on the dispense platform, the refill light will come on, and the pump head will not dispense until a new concentrate package is placed and the concentrate covers the pins. We call this lockout mode disabled. With the jumper in covering the J5 and middle pin, the refill light alone will come on when the concentrate package empties, but the pump will continue to dispense water. We call this refill light only the enabled mode. All Quest dispensers are shipped in the enabled mode. If the jumper is missing, the default mode is enabled. Every Quest dispenser comes with a sold-out indicator system included. The bottle adapters mounted on the dispense platforms have 2 pins, the high and low sensors, built in. They are wired to the corresponding VRB board at the 2-pin sold-out connector. Very low microvoltage current runs through these 2 pins. When the concentrate package is engaged and concentrate flows over these pins, the circuit is closed and the refill light goes out when the door is closed. When the concentrate runs out and the pins become uncovered, the refill light comes on, enabled, or the pump head stops with the illuminated light, disabled. When the door is opened, the reset door switch cuts the 26 alternating current voltage to the electrical box and the VRB boards. The concentrate package is loaded and the pins are covered again. When the door closes, the switch engages the 26 volts AC to the E-box. With the concentrate itself completing the circuit, the system is activated and the light goes out. Every VRB has a 3-second delay before the system indicates refill, so as to accommodate any small interruption in concentrate flow, such as an air bubble in the bottle. Upon resetting, the VRB board must be deactivated for a period of at least 10 seconds or about the time it takes to remove the old package and replace with the new. Any time that is shorter than 10 seconds, the VRB will not reset and the refill light will remain on.
The first indication there is a problem with the dispense circuitry is that the 6 1/4 amp slow blow fuse is blown out. Remember, when this fuse cuts the 26 volts AC from the transformer to the electrical box, thus no dispensing on any valve will take place until the fuse is replaced.
First, remove the box and verify the fuse is indeed blown. If so, replace the fuse. Before replacing the electrical box, inspect each VRB for any burn marks or components or a deformity of the capacitors. A bad board capacitor sometimes will show up with the top of the capacitor being pushed upward. If any burn marks or blown-out components are visible, it is imperative that the dispense platform pump and solenoid for that particular head be checked. This condition indicates a possible shorted solenoid coil or motor, and they should be checked and replaced if necessary before activating the replaced VRB. Pull all the 26 volts AC inputs off of each board, leaving just one remaining. Plug the box in to energize. If the fuse remains okay, do this for each input. Repeat this procedure one at a time until all inputs are replaced. This is checking to be sure none of the VRB boards have a dead short causing the fuse to blow immediately. If none of these conditions is present, replace the box in the unit. Activate each pump head one at a time until the fuse blows out again. That will be the board that will need to be changed. The easiest way to remove these boards once the transistor hardware and all the connectors are removed is to push the standoffs from the bottom side of the electrical box so that the VRB and the standoffs come out of the box as an assembly. The standoffs can then be removed and added to the replacement board more easily. Interrupted dispense shows up with the dispenser stopping in the middle of dispensing both water and concentrate even with the button pushed. When the button is released and activated again, the pump head starts again only to repeat the problem. This is a direct result of the drive transistor not drawing enough heat away because of loose or improper mounting. The screw must be tight, the washer in place correctly with the transistor making full contact with the insulating pad and the bracket. If running in low speed, this condition may be more prevalent as all the heat is generated by the primary, mounted, chip when both transistors are activated, which is done in low speed. If no hardware is present, dispensing itself will last only 2 or 3 seconds. Repeated too many times, the VRB will sustain permanent damage. Another problem is caused by improper mounting of the drive transistor hardware. If the transistor itself comes in contact directly with the bracket, it becomes grounded. When any of the other dispense heads are activated, current will flow through the chassis ground, thus activating the drive transistor that is in direct contact with the mount bracket itself. This will only happen for a short period, as this condition will permanently damage the VRB board. A point that is sometimes overlooked is the mounting of the shoulder washer. The shoulder itself must fit up into the hole in the transistor to be sure the screw itself is not making any contact, thus grounding out the VRB. This condition indicates a sticking relay on the VRB. Although it may be sporadic, if the relay sticks once, it will stick again and the VRB should be replaced. All Quest juice dispensers have 2 dispense options, press and hold, and 4-size programmable portion control. This change is easily done by simply changing out the lower door assembly. The portion control timers are part of the switch assembly themselves, so nothing else changes in the dispenser itself. Programming is simple. To place the switch into the program mode, you need to press the small cup and the pitcher symbols simultaneously. If successful, the refill light will blink, showing you that the keypad is in program. Begin with the small size and fill the glass up to the desired level. You can top off the level as the timers are designed to build time. Repeat for all the remaining sizes. Once you have completed all 4 sizes, press the button with the 2 arrows and the refill light will go out. Now you have exited the program mode. This is a timer. If you experience an inconsistent fill, it could be that the water pressure to the unit is fluctuating. This will show up if all dispense heads are experiencing inconsistencies. If only one is, then it's probably the timer board itself.
One of the unique features of the Quest Juice Dispenser is the modularity of the pumping platform. The entire pumping assembly can be removed for cleaning, replacement, and repair. There are 3 key components: the bottle adapter, the pump and the motor, and the flow control assembly.
The bottle adapter assembly is where the concentrate package engages the dispenser. This is done with this inverted U-pin pushing up on the ball check that is attached to the concentrate package itself. When engaged, the concentrate will flow through the adapter and be pumped through the platform to the mixing chamber, where it is mixed with metered water and dispensed through the nozzle as the finished drink. The adapter has 2 modes of operation: dispense as described above, and flush. In the flush mode, the concentrate flow is shut off at the neck of the adapter. At the same time, the potable water is redirected into the pump system itself. When you activate the dispenser in this mode, you are flushing the concentrate lines, the pump tubing, the mixing chamber, and the nozzle and mixer assembly. There is a series of O-rings that make up the bottle adapter assembly. It is key to the proper operation of this assembly that these O-rings are properly lubricated and remain in the correct positions. The adapter has 3 parts: the top, the slide or lollipop, and the bottom. Worn or dried out O-rings will show in a couple of ways. If these larger O-rings are worn, you will start to see traces of concentrate between the sections. This is very pronounced with your thinner concentrates such as cranberry or fruit punch. If this small O-ring is not sealing properly, you will find that when dispensing on any valve, water will flow up through the neck of that adapter, filling the concentrate package on every dispense. Remember that the water manifold is common for both platforms. When activated, the rear solenoid opens and the water flows up to the platform through these quick disconnects. This small O-ring must be sealing properly to prevent water from flowing up the neck of the adapter, which is open to let the concentrate flow. During replacement of all O-rings, use a small amount of food-approved, non-petroleum-based lubricant. Do not over-lubricate, as the O-ring may not stay in place and lose its seal. When reassembling, the large O-ring may be pinched if not installed properly. Place the slide valve into the bottom of the adapter, keeping it straight across. Press evenly to seat the O-ring. Do not rotate the valve back and forth when seating the O-ring. Do the same when installing the top. When securing the screws, do so in the X pattern, tightening the opposites across from each other. Be sure they are fully tightened to prevent leaking. Located on all adapters is a micro switch. It is connected to the sold-out pins in the adapter neck. Its purpose is if the unit is being operated in the disabled sold-out mode, that is, when the out-of-concentrate light comes on and the pump head stops dispensing, the system can be flushed before reloading the concentrate. The lollipop in flush mode closes the switch and allows the pump head to activate. When the unit is in the enabled sold-out mode, refill light only, the switch has no function. These are 28 direct current voltage geared pump motors connected directly to a 3-roller peristaltic pump. Since these are DC motors, they will run backwards if they're not wired correctly. The wires are color-coded for that reason. You will see that the rubber boot that protects the motor from moisture has changed color from orange to red. Although these red motors are identical in application, they are geared differently, so turning them by hand is more difficult. Do not make the assumption on the red motors that if they do not turn, they are locked up. Try with a pair of pliers. If the motor is good, it should turn with pliers. The pump rotor has 3 rollers. These rollers must spin freely in order to accurately dose the concentrate into the mixing chamber. The best and easiest check is to pull the rotor out of the pump itself. This is done by removing the 4 screws and separating pump halves. Keep the tubing pushed up and out of the way. Pull the rotor assembly straight off. Spin each roller to check for binding. If found, replace the rotor. Another indication is if you find rubber shavings in the bottom of the pump halves. This indicates a binding roller. Do not lubricate the rollers or the pump tubing at any time. The pump tubing is a peroxide impregnated silicone tube that will stand up to 3 million cycles before it needs replacement. We recommend a once-a-year change-out or any time a unit has been sitting idle for long periods of time.
A key point to remember is if the customer consistently uses the flush mode to dispense water only, the pump tube at the top of the pump inlet eventually is going to balloon and then split. Flush is for flushing only, not dispensing water. This condition is more likely to happen when the incoming water pressure to the unit is over the recommended 50 psi.
When reassembling the pump assembly, be sure that the tube is placed in the pump head grooves and is not pinched where the front and back halves are reassembled. The flow control is the ceramic spool and sleeve. It must move freely to regulate the water flow and thus maintain bricks. It is turned clockwise to increase the water flow and counterclockwise to decrease the water flow. These are pressure compensating flow controls. They work best when the incoming pressure is regulated to 50 psi. Their effectiveness is significantly reduced if the water flow is less than or greater than 50 psi. Again, the operating range is 20 psi to 80 psi. If the control is not regulating the flow of water when turned, 2 possible scenarios are taking place. The spool itself could be hanging up in the sleeve, or the sealing O-ring at the rear of the sleeve is letting the water leak past the control. In the case of the sleeve not reacting to adjustment, the first step is to back the adjusting screw out until it hits the stop. Close the door and press the dispense button numerous times in short bursts. Run the screw in by turning clockwise and repeat. Finally, back the screw out to the stop again. Even with the adjusting screw backed out to the stop, meaning the valve is in the closed position, at 50 psi there will be a very small stream of water flowing when the valve is activated. If running the adjusting screw in and out does not solve the problem, then the valve will need to be disassembled and checked. These controls are ceramic. They will break if dropped and can crack if care is not taken when removing them from the valve block assembly. The nozzle and static mixer are designed to give a well-mixed, finished drink even with heavy pulp juices. If the static mixer has been damaged to where any of the 3 feet at the bottom of the mixer are broken, this process will be compromised and the mixer should be replaced. If the nozzle and O-ring are subjected to repeated dishwashing or allowed to stay for prolonged periods in sanitizing solution, the nozzle barrel will shrink, causing problems inserting the mixer. Another way this will show up is there will be after drips from the nozzle itself. The O-ring allows the nozzle to hold a vacuum, thus keeping it filled with juice so there's no interruption in the flow of drink from dispense to dispense. If the nozzle does not fit properly or the O-ring itself is damaged, air will be allowed to enter and there will be a constant drip until the nozzle is drained out completely.
Cornelius Warranty is administered through its website. All Quest dispensers carry 1-year warranty on parts with 4 additional years on the compressor. All Cornelius products leave the factory with a serial plate. It's very important with any inquiry to tech support or warranty that this number can be presented. In addition, this number is a manufacturing date code that can be very helpful to you in determining the age of the dispenser.
The serial number is a 12-character alpha and numeric sequence that gives the following information. First 2 numbers indicate the Cornelius manufacturing plant where the unit was produced. For juice, currently it is 62. For older units, 72. Alpha number 3 indicates the revision level of that particular unit. Anytime there is a major change or upgrade to the unit design or components, this alpha character changes. Currently, units are at an F revision. The next 4 numbers indicate the year and week of manufacture. The next 2 alpha characters are the item designation in the case of Quest JT. The last 3 numeric are sequence numbers. These indicate what number that particular unit is of that week's production run. The serial plates are located inside the door as well as on the frame behind the right-hand side panel.
This completes the technical review of the Cornelius Quest 4000 dispenser. In addition to the operations manual that comes with every dispenser, additional technical support is available at 800-238-3600. Thank you for watching and good luck keeping your Quest 4000 up and running.